Hey guys, this is Encrypit. It's a hidden calculator encryption vault. The calculator operates as a normal calculator would until you enter a specific expression and hit the equals sign, at which time a second activity is launched. This second activity displays a text field that the user can encrypt and decrypt the contents of. The calculator is XML text views in a column of rows for buttons and two display fields for the expression and the result. If the numbers in the expression field don't match the numbers the passcode requires, it operates as a normal calculator would and displays the result. Once the user is through the calculator and in the encryption application, they can edit the text in the text view field and either encrypt or decrypt the contents of it. My application uses Android cipher class to generate a cipher object that performs encryption methods on the plain text given to it. When instantiating the cipher object, you have to pass in the transformation function, the padding mode, and the block cipher mode, as well as your secret key. This cipher uses AES encryption and the GCM block cipher mode with no padding. The cipher's initialization vector is needed to generate the decryption cipher, so we set a reference to it after the cipher is initialized. Before the user can either decrypt or encrypt the contents of the text field, they need to specify a key alias. To do that, the user clicks on the key alias button and inserts a unique key ID. The same key is needed to decrypt. If the incorrect key is given, a toast dialog displays that the encryption is a failure, and if the correct key is given, a toast dialog displays that the encryption is a success. I use the Android key store system for storing the keys. This is a cryptographic key container that makes it difficult to extract the keys from the device, so that they can be used for cryptographic operations from within the container while remaining non-exportable. The decryption method of the cipher requires a secret key and a GCM parameter spec object to be instantiated. This GCM parameter spec object is instantiated using the same IV that we passed out on cipher generation during decryption, as well as the total bit length of the GCM. This is done so that the block mode cipher operates under the same IV and bit length as the encryption cipher did. In order to obtain the secret key required by the cipher initialization, a key store instance is created so that we can retrieve the same key used during encryption. This key is generated using a getEntry method and then initialized to a secret key object. Once the GCM spec and key objects are instantiated, the cipher is initialized with these two objects, and the doFinal method is called on the cipher object with the test file's bytes as input. The resultant bytes are cast to a string and written out to the same file. Both encryption and decryption read and write from the same file. As for limitations of the application, there was some difficulty storing the IV in a persistent way so that the application could be open and closed, and the same IV that was used in cipher generation could be maintained for decryption. But I couldn't figure out the Android shareable preferences in time. I meant to use that to store the calculator password too, so that could be updated. These ended up being goals I wasn't able to meet. So here's a quick demo of my app Encrypit. It works as a standard calculator until you give it the correct sequence. In this case, it's 42 for obvious reasons. The sample secret text is editable. So you can edit this text field and encrypt it, which will not work until you give it a key alias. So we have to give a reference name to the key that we're storing in the key store, and you encrypt it, and it writes out the bytes. Now, if we were to overwrite that key with something else, we would not have reference to the correct key in the key store, so we wouldn't be able to decrypt it. So we give it the proper reference to the same key used in encryption, and we decrypt it successfully. This is the calculator password that I wasn't able to get quite up and running, but it would have been cool if I did, so I just left it there. And that's my app. Thank you so much for watching.